A microscope is a tool that makes tiny things look larger, so eyes can explore objects too small to see alone. Under the lens, everyday crumbs become landscapes. A grain of sand turns into a jagged boulder. An onion skin can show neat rows of little boxes called cells. Sometimes a clear drop of pond water looks empty at first, then shows drifting specks and wiggling shapes. What might be hiding in that drop? Most classroom microscopes are light microscopes. A lamp or mirror provides the light, and curved lenses bend it to form a magnified image. In a compound microscope, an objective lens sits close to the object and makes the first larger picture. The eyepiece enlarges that picture again. Twisting the nosepiece swaps objective lenses, changing magnification. A 10 times objective with a 10 times eyepiece gives 100 times, and some light microscopes reach about 1,000 times. A sample usually rests on a thin glass slide, held on the stage with clips. The coarse focus knob can move the stage more noticeably to find the image, and the fine focus knob makes tiny adjustments until details look crisp. An iris diaphragm helps control how much light comes through, so pale cells don't fade into glare. Scientists also talk about resolution, meaning how close 2 points can be and still look separate, not smeared together. Microscopes have a long story. Compound microscopes appeared in Europe around the early 1600s, and in 1665 Robert Hooke published Micrographia with drawings of tiny details, including cork, that reminded him of small rooms he called cells. Later, Antonie van Leeuwenhoek used strong single-lens microscopes to observe microorganisms. To see even smaller structures, electron microscopes use beams of electrons instead of light, reaching up to about 1,000,000 times magnification.